In section 4.3, we learned the basics of solving equations. We learned that you can add any number to both sides, and we learned that you can divide both sides by anything but 0. Well, in section 4.4, we're going to continue with that, except our equations are simply going to be a little bit more complicated. For example, we might have 5x minus 1 equals 9. Our goal is to isolate the x. We notice that we have a multiply by 5, which tells us we're going to need to do a divide by 5 to get rid of that. And we notice that we have a minus 1, which means we're going to have to do the opposite of that, which is a plus 1. Now, typically, we do the adding and subtracting first. You can actually do them in any order. Typically, we do the adding and subtracting first. We would add 1 to both sides. We would have 5x equals 10. And then we would divide both sides by 5. I'm thinking ahead. I'm thinking of the answer. And our final answer would be x equals 2. All right. Homework, as you might have suspected. All right, C. C is a very important one. And what I want to talk about on C is the very, very common mistake that all C people make. We have 4x plus 3 minus 9x equals negative 22. We want to combine the x's. We got more than one x, we need to get them together. Here's the mistake I will see people do. Don't do this. I will see people put plus 9x plus 9x. And then they'll write 13x plus 3 equals minus 22. Why is that wrong? Well, the rule is you can add things to both sides of the equal sign. We didn't add to both sides of the equal sign. We only added on one side. That's very, very, very illegal. Please be very careful of this and don't make the mistake. If both things are on the same side of the equal sign, we simply combine them. So what we should have here, 4x plus 3 minus 9x equals minus 22. We notice we have x's on the same side of the equal sign. For just a minute, we completely forget about this equation and we just deal with this expression and we simplify it. 4x plus 3 minus 9x, we put the x's together, that's minus 5x. Notice we're not adding to both sides, we're just combining like terms. Now we solve as normal. We subtract the 3 on both sides. That gives us minus 5x equals minus 25. We divide both sides by minus 5. And we have x is 5. All right. Homework. Oops, slide that over so you can see my final answer. X is 5. Okay, E. E, now we do have x's on both sides of the equal. So now it is appropriate to do a minus 4x on both sides to combine those x's. So notice the huge difference here. In part C, both the x's were on the same side of the equation. We simply combine them. On part D, x's are on different sides of the equal. So we do a minus 4x on both sides. Alright, so that's going to give us 3x plus 5 is 17. We next subtract the 5 on both sides. 3x is 12. And finally, now this is connected by a multiply. Since it's connected by a multiply, we do a divide. X is 4. Up to this point, all of our numbers, all of our answers have come out very nice. No fractions, no decimals. Don't expect that to always happen. There's absolutely nothing wrong with getting fractions or decimals for answers. It simply hasn't happened yet. F, another homework problem. G, alright. Couple things on this one. First thing I notice is I have parentheses here on this side of the equation. I need to get rid of those. I need to clean up that left side. So I distribute minus 3x plus 12. Watch that sign there. That's a negative 3 times a negative 4. It's a plus. 2x plus 2. Now, I once again notice that I have x's on both sides. I have to move one of them over. Just to be different, just to show you there's nothing wrong with this, I'm going to add 3x, and I'm going to put all the x's on the right-hand side. Some people don't like to do that. Some people like to always put the x's on the left. If you want to always put the x's on the left, that's okay with me. Other people say I'm always going to move the smaller one, and that'll help keep numbers positive. That's okay with me too. That's a personal preference. Whatever works for you. It is kind of nice to have that be a positive instead of a negative, but truthfully not a big deal for me. We now subtract the 2 on both sides. 10 equals 5x. That 5 is connected by a multiply, so we get rid of it by doing a divide. X is 2. Now it wouldn't hurt, I haven't done this up to this point, it wouldn't hurt to check my answers. I'll do it for this last one. I don't typically require you to check, but it's a very good idea, and you can usually see quite quickly if you have the right answer or not. So I would take negative 3 times 2 minus 4, so I'm just taking 2 and plugging it in right there. Is that equal to, I'm going to take the 2 and plug it in over here too. 2 times 2 plus 2. Well, let's see. 2 minus 4, that's negative 2. Move it over a little bit more. 2 minus 4 is negative 2. Negative 2 times negative 3 is 6. Over here, 2 times 2 is 4. 4 plus 2 is 6. So I'm very sure I have the right answer. 6 equals 6. All right. Moving along here. H. Another homework problem. I. All right. I has lots of stuff going on here. Notice that we have parentheses on the right hand side, we have parentheses on the left hand side. We have to clean it all up before we can try to solve. So this one's going to take some space, so I'm going to write up over in here so I have room. Now, a very, very, very common mistake that I'll see. People will go 3 minus 4 right here and write minus 1. Can't do that. And it's an order of operations thing. In the order of operations, what comes first? Subtracting, or there's a multiply right there, and I hope you would agree that the answer is multiply comes first. So what I have to do on this left hand side is I have to take this minus 4 and distribute it before I can do the 3 minus 4, because multiply comes before subtract. So I'm going to have 3 minus 12p minus 8p. I distribute the minus 4 through. On the right hand side, I'm going to do pretty much the same thing, except it's just a minus 1. And people don't usually mess this one up because there's no number there. They usually recognize we have to distribute here. So I'm going to distribute 7 minus 9p plus 1. Again, being very careful. Notice I have a minus and a minus. Give me a plus. All right, well, that's a good start, but not as far as we need to go. What I mean by that is, I notice I have like terms on this side of the equal, and I also have like terms on that side of the equal. I need to continue to clean up here. I'm going to do minus 12p minus 8p. That's going to be a minus 20p. I still have the 3 there, so 3 minus 20p equals, over here, I guess I'll write the minus 9p first, and then 7 plus 1, that's 8. Alright, I have cleaned up the left hand side and the right hand side as much as I can. Now I notice that I have variables on both sides. I need to get those together, so I do a plus 9p. That gives me 3 minus 11p equals 8. I subtract the 3. Minus 11p is 5. Finally, to get the p all by itself, I divide in. Here's a good example of what I said a few minutes ago. It's okay if your answers come out to be fractions or decimals. I would write my answer as p equals minus 5 over 11. Typically, we're going to leave our answers as fractions. We don't want to use a decimal because this is one that would go forever and ever and ever. It would have a pattern to it, but better to leave it as a fraction. All right. Well, by this point, you're probably not surprised. Homework problem. Okay, problems with fractions. Many students see equations and the equations have fractions and they don't like it. Fractions should not bother you all that much, because here's what we're going to do. We're going to look at the fractions, and we're going to look at the denominators, a 3 and a 2, and we're going to find the common denominator. The common denominator is 6. We're going to take that common denominator and we're going to multiply it by every single piece. I'm going to take 6, multiply it by 4/3 x, minus 6 times 2. Even though that one's not a fraction, I multiply that. Basically what I'm doing is I'm taking the number 6 and multiplying it on both sides of the equation. That was one of our rules, that we could multiply and divide by any number. So I multiplied everything by 6. 6 was my common denominator. Here's why. I think of 6 as being 6 over 1, and I can reduce there. And I'm left with 8x minus 12 equals 18x plus, same deal over here, I think of 6 as a fraction, I reduce, 15. Notice how nicely that works. We multiply by our common denominator. Multiplying by the common denominator clears all of the fractions, and that's what we wanted. Now it's very similar to many problems we've done so far today. We get the x's together. Minus 10x minus 12 equals 15. We get the numbers together. Minus 10x is 27. We divide. And again, I'm going to leave my answer as a fraction. I would greatly prefer fractions to... Ooh, I almost made a mistake there. Dividing by negative 10. We're going to leave our answers in fractions most of the time. Although this one would be okay as a decimal, it would just be minus 2.7. Not bad. But again, general rule is, if your problem starts with fractions, your answer should be a fraction, not a decimal. It could come out to be a nice number, but if it's not a nice number, if you start with a fraction, the answer is a fraction. All right. 2 more homework problems for you. Okay, here's the other thing in this section that's new. Solve the following. State whether the equation is a conditional equation, an identity, or inconsistent. Okay, all of these equations we've solved so far, these have been conditional. And what conditional means is you get one answer. For example, equation K. Equation K is true only under the condition that x is negative 27 over 10. And that's why it's called conditional. You get exactly one answer. A here, on the other hand, if we try to solve A, we have 6x equals 6x. When does 6x equal 6x? Well, 6x always equals 6x. It wouldn't matter what number we plugged in there, we would always get a true answer. That's called identity. Identity is a fancy way to say always true. So that our answer there would simply be identity. That one's always true. And that brings us to the other option was inconsistent. Well, I'm guessing B here is inconsistent. Let's find out. If I try to solve B, I combine my like terms. 4x minus 2x is 2x. So I have 2x minus 5 equals 2x minus 1. I get my x's together. I do minus 2x. And I notice something very bizarre happens. 2x minus 2x, that's 0. The x's go away. I get minus 5 equals minus 1. When does minus 5 equal minus 1? The answer is never. and that's called inconsistent. Consistent. I spelled that wrong. Inconsistent. There we go. That's better. And what this simply means is it's never true. There's no answer. Okay? And you can tell inconsistent by you get something that is clearly wrong, something clearly not correct. Alright, so you're going to do C, D, and E. You're going to decide if you can solve those, or you're going to decide if they are identities, or you're going to decide if they are inconsistent. The last thing, we have some word problems. In 2012, a 1-year-old Subaru Outback was worth $25,772 with a depreciation of about $1,976 per year. Determine a linear equation to model the situation. Explain the meaning of your variables. Okay, what I mean by explain the meaning of your variables is normally when we write a linear equation, we write y equals mx plus b. I'm not going to use y equals mx plus b. I'm going to use a v equals mt plus b, where t is years since 2012 and v is the value of the car. So when I say explain your variables, this is what I expect to see. I expect to see little sentences like that, if you will. They're not correct sentences, I guess, but you get the idea, I hope. And there's a very good reason for doing this, and we'll see that more in part B here. Okay, so now I need to decide what my slope is and what my b value is. Where's my y-intercept? I notice that 1976 is the slope. And I notice that it's the slope because it has per year. Slope always comes with a per, because it's dollars per year. It's value divided by time. It's y's divided by x's. So we're going to have v is 1976t plus b is 25772, because b would be the value at year 0, and year 0 is 2012. So my y-intercept, my v-intercept would be 0, 25772, so that's the b value. Estimate when the car will be worth $6,000. Here's why it's very, very important to explain what your variables are, especially if you're using x and y. $6,000. Is 6,000 a t value or is it a v value? I think pretty clearly here it's a v value, it's value. But if you just wrote y equals mx plus b, it's very tempting to take this 6,000 and plug it in for the x number. And that would be wrong. 6,000 is a v number or a y number. That's why it's important to write down what your variables mean, so when you go to plug in numbers, you make sure you plug them into the right spot. That's one of the most common mistakes I will see. People will take the number and plug it in for the wrong variable. So we're going to have 6,000 equals, oh, I made a mistake here. Oh, I caught myself though. My mistake is I forgot about the word depreciation. That means the value is going down, which means my slope should have been a negative number. Alright, so we'll fix that. 6,000 equals minus 1976t plus 25,772. To get the TL by itself, I subtract the 25,772 on both sides. And I'm going to use my calculator. 6,000 minus 25,772 is minus 19,772, and that equals minus 1976t. I divide both sides by minus 1976, and I have t is 10.006 years. We're just going to call it 10 years. So we started in the year 2012, so this would be in the year 2022. Okay, well, it comes as no great surprise. Problem 4 for homework. Once again, bring all these problems to the next class period. If you have questions, of course, send me an email. Stop by my office. Go to the Math Learning Center. The important thing is get help. If you have questions, make sure you get help.